Okay, so welcome to the composite figure reteach. This will be for questions 1 through 5 on the test. If you need the surface area reteach, you need to watch the other video. For your corrections page, you need to split it into 2 columns. You need to split with the left side being where you're going to show your work, your answers, and the right answer. On the right side, in your own words, you need to put why you think you got that question wrong. Now, on the questions that you got right, there's no need to do corrections, so you only need to do the ones that you got wrong. Okay, question 1. Find the area of the composite figure below. Now this is going to be an addition problem because it's not asking for any shaded region. So I know I'm going to be adding at least 2 shapes together. Also, we're going to have to look for some missing sides in this example. So what we need to do first is determine what 2 shapes do we see. Now obviously we can split this shape down the middle right here to create a square and a rectangle. What you need to do is separate the shapes individually and draw them out to the side. So I could draw the square out here to the side, and then I have a rectangle. Again, addition problem, so I'm going to add these 2 shapes together to get a total area. Now with area, remember, we're looking for the amount of space on the inside. So my formulas for a rectangle and for a square are both A is equal to a base times height. Same thing here. A is equal to base times height. So, well, what do I know? Well, I know the top of this square right here is 4. As well as the side over here is 4. So if I use the formula area equals base times height, that gives me a total area of 4 times 4, which gives me a total area of 16. So my square is 16. Now we need to look at the rectangle. Well, what do I know already from the rectangle? I know that the length over here is 6. We can say that's the height. What I need to know now is what is this base right here? Well, what else do we know? We know that a square, all 4 sides are the same. So if the top of the square is 4, that means the bottom of the square right here has to be 4. Why is that important? Well, that's important because if I know the whole length of the shape is 8, and I know from here to here is 4, and again, the whole length of the shape, and I'll draw down here, from here to here is 8, how much is left over for the rectangle? Well, to figure that out, I'm going to take the 8 for the rectangle, and I'm going to subtract out the 4 from the square. That gives me a total length for the rectangle as 4. So when I find the area, I plug into my formula, area equals base times height. Well, I'm looking at area equals 6 times 4, so that gives me a total area of 24. Now we go back to the original question is, how do we find the area of the whole shape? Well, because since there's no shaded region, we add the 2 numbers together, so I'm looking at 16 plus 24 for a grand total of 40, which is answer choice A. So again, if you missed this question 1, what you need to do is go ahead, if you need to, pause the video, figure out where your mistake was, make sure you circle the right answer and show your work on how you made the correction. Then on the right hand side, go ahead and tell why you think you got this problem wrong. When you're ready, move on to question 2. Okay, question 2. Again, this is another addition problem. We have to first determine what shapes do we see. Now I see, when I draw a line right here, again I have a triangle on top, and then again I have a rectangle on bottom. And now how do I know this is not a square? Well, when we look at the measurements, we have a 7 here, and then an 8 here. So that tells me that this is a rectangle. Also, I already have my base and height because I know the formula for rectangle is area equals base times height. So I'm going to go ahead and plug those numbers in over here so that way I can see them. Next, we have a triangle. Now the triangle formula is the area is equal to 1/2 base times height. So we'll come back to the triangle. First, let's do the rectangle because that's the easy one. So when we find area equals base times height, I say, well, what is 8 times 7? That's going to give me a grand total of 56 for the rectangle. Again, we're adding these two together. So I'm going to redraw the triangle a little bigger so that way we can see it. And draw it down here at the bottom. And remember, I'm looking for the base times the height. Now, what we have to talk about is composite figures share sides. And so what do I mean by that is that when we have more than one figure, they are going to share at least one side together. And in this case, that side's going to be right here at the top of the rectangle, and that's going to be the actual base of my triangle. So how does that help me? Well, that helps me because then I can look at, well, if the bottom of the rectangle is 7, that means the top of the rectangle also has to be 7, which tells me that the base of my triangle is 7. Now to determine the height. To determine the height, we need to look at the triangle's perpendicular distance from the top of the triangle down to the base. Now perpendicular distance is meaning like, well, where can I make a right angle? Remember, right angles are straight lines where they all come together. If I draw a dashed line, that is the height of the triangle. Now don't get confused and think that the height of the triangle, because they will like to put a measurement right here. Okay, that is not the height. What we're looking for is how long is the distance from the top of the triangle down to the base. Okay. So what we need to do is determine, well, what can we use to help me figure out that? Now if we look over here, let me erase this. Okay. We see that the measurement of the whole shape from top to bottom is 13. What we know about rules of rectangles is that we say opposite sides are the same. So if we had a bottom of 7, our top is 7. Now my left side is 8, so my right side has to be 8. Well, why is that important? It's important because we now know the distance from here to here is 8. What I need to know is, well, what is the distance left over to get to 13? So I know I started with 13. I know my rectangle is 8. Well, how much do I have left over? Well, that's just a simple subtraction problem. 13 minus 8 gives me a grand total of 5. So the height of my triangle here is 5. So to find the area equals 1/2 base times height. I'll write it up here so where we can substitute. I'm going to plug in what I know. So I know that the base of the triangle is 7. The height of the triangle is 5. And I have this 1/2 here. Now, a very common mistake that students will make is that they will multiply the two numbers and stop. Remember to go back and take half. And when you take half of a number, that's simply taking that number and cutting it into two sections. So it basically is saying the same thing as dividing by 2. So let's see what that is. So if I multiply out, I get 1/2. 7 times 5 is 35. And half of 35 is... going to be 17.5. So I know my triangle now is 17.5. Okay, so now I have the two numbers I need, so now I need to add them. So let me clear some space so that way we can add them. So I'm going to say 56 plus 17.5. Now, before I write 17.5, another common mistake students forget to do is line up the decimals when they add. So remember, when you add or subtract decimals, the decimals have to align. They have to be lined up on top of each other. So when you think of it, the way you think of writing a whole number as decimal is to think of how would I write $56? Well, I would write it as 56.00. Well, we only have one decimal, 17.5, so we don't need to add the other 0. But now I can align my decimals up. 0 plus 5 is 5. Bring down my decimal. 6 plus 7 is 13. Carrier 1. 5 plus 1 is 6. Plus 1 more is 7 for G, 73.5. So again, if you got this question right, you don't need to do the corrections, or you could have just moved on. If you did, unfortunately, get this question wrong, go ahead and show your work on your corrections page, and then tell your teacher in your own words why you think you got it wrong. 24. Oh, excuse me. I don't know what happened. Okay, so question 3. Now, this is going to be a subtraction problem because what it's saying is we need to find the area of the keyword here is shaded. Shaded region is telling me that I need to subtract out the numbers. Also, if we have a shape inside another shape, that's also going to tell me that we're going to be doing some kind of subtraction. Okay, so let's look at the two shapes we have here. I'm going to go ahead and get rid of that. So also, obviously we're dealing with a circle, and it's telling us right here explicitly we need to use 3.14 for pi. Now, if this was a multiple choice question, meaning that we had answer choices A, B, C, or D, then we could probably get away with using 3, which we will see later in this example of a reteach. But for this case, since it is an open-ended question where you have to fill out your own answer in the bubbles, you have to use 3.14 for pi. Okay. So let's look at, again, what two shapes do I see? Well, I see a square and a circle. Now, how do I know that it's a square? Well, obviously it's a four-sided figure with 4 right angles, right? That's easy to see. But if it only gives us one measurement unit, and though it's four-sided, that's telling us the test is assuming that you guys are going to understand that means that all sides are 6. Okay. Now, my formula for square is area equals base times height. So what do I know? Well, I know the base is 6, the height is 6, so area is equal to 6 times 6, which is 36. Okay, so I'm going to put that number down here. Now remember, we're going to subtract out. We're always going to subtract out the outside shapes area minus the inside shapes area, because obviously in order to fit inside something, you have to be smaller. So we want to start with the bigger number so that way we don't end up with a negative. So now we have this circle, and I know my formula is pi r squared. Now just to review, r squared, okay, that means the radius squared, which also means the radius times the radius. Remember this exponent here, okay, the number there tells me how many of these I need. It tells me I need 2 radiuses. Now, how do we find the radius from what we're given? Well, what we know is that this distance across the square is 6 units. Now, it's 6 units no matter where you move up or down along that square. All of these are 6. Okay. Now, what we know from our past unit is that diameter is the distance across the circle from edge to edge through the center, which is also saying the same thing as, well, if this right here, this line right there, is the diameter. So I know the diameter is equal to 6. I also know that the radius is the diameter divided by 2, which is the same thing as saying 6 divided by 2, which gives me a radius of 3. Now that we know the radius, we can now substitute and plug in for our formula for pi r squared, which I'm going to do down here. So I have area is equal to pi, which we know is 3.14, times the radius squared. And the radius is 3, and I'm squaring it. Change that to black. All right, now I'm going to start with the 3 squared, or I'm going to expand the problem so you can see it. I'm going to say a is equal to pi times the radius squared, and I'm going to use the dot for multiplication. Now we know what I said earlier is that tells me how many of these I need. So I need 2 3s. Now with multiplication, it doesn't matter what order you multiply in. Now we could start with 3.14 times 3. Okay, or 3.14 times 3, either one. But obviously, let's do the easier one first. And we all know that 3 times 3 is equal to 9. So I'm going to say I'm going to simplify down to 3.14. And I'm going to put this one in parentheses to show you that it doesn't matter what sign we use. We can use a dot, an X, or a parentheses. We tried to need to move away from the X, but we should use a dot and parentheses for multiplication. So now I just need to figure out what is 3.414 times 9. So I'm going to clear some space so that way we can look at that. All right, so remember, with addition and subtraction, it's important to line up your decimals. With multiplication, it's not that important. We don't have to line up the decimals with multiplication. I put the bigger number, the more digits on top, it's just easier for me to multiply. Now, 3.14 times 9, well, 9 times 4 is 36, carry my 3. 9 times 1 is 9, plus 3 is 12, carry your 1. 9 times 3 is 27, plus 1 is 28. Now, what I've taught is to go back and count your decimal places. Well, I have 2 decimal places on top, 0 on bottom, so 2. That means I need to move the decimal at the end 2 times to the left. So then I get 28.26. So now I have my area of the square and my area of my circle. Now, one of the mistakes I saw was a lot of people gave this as their answer choice. Now remember, we are not done. We have 2 shapes, so we're always going to have to do something more. Okay, this is not the unit where I'm asking you to, or we're asking you to find the area of a circle. We're asking you to use what you know to extend your thinking a little bit farther. So we still need to figure out the total area of just the shaded region. To do that, remember, I need to take the area of the square, and then I need to subtract that now from my area of my circle. We do have a decimal, so again, when we are adding and subtracting, we have to line up the decimals. And again, with whole numbers, we write them like dollars. So 36 as a whole number would be 36.00 minus my area of my circle, which is 28.26. When I subtract that out, I borrow here, this becomes a 5. This is going to become a 9, that's a 10. Get 4, 9 minus 2 is 7. Bring down your decimal. I have to borrow again. 15 minus 8 is going to give me 7, and that is the area of the shaded region. So again, if you got this one wrong, go ahead and tell us why you think you did. A lot of common mistakes, like I said, where you stopped at the area. You didn't use the right radius. Also, very common mistake was we saw a lot of 6s for the radius. Remember, that's the diameter. And then make sure you line up your decimals when you add or subtract. And then up here, make sure you go back, up here the multiplication, make sure you go back and count your decimals correctly. All right, number 4. Okay, now there's a couple ways you could look at this. I'm going to show you guys the majority of the way how most of you solved it. You guys solved it with 3 shapes. You could have solved it with 2 shapes where you have a semicircle and then you have a trapezoid. Now, that I know trapezoid is a big scary formula, so I'm going to go ahead and stay away from that for now and show you guys mostly what most of you guys did. Again, no shaded regions here, so this is going to be a addition type of problem. So first thing I'm going to do is isolate the shapes independently. So I'm going over here and physically draw them off to the side. Semicircle, again a rectangle because they don't have the same lengths, and then the right triangle. Okay. Now, this is a multiple choice question, so you will be able to use 3 for pi. So let's go ahead and add that here. So if you'd like to read the word problem, it says Landon uses a semicircle, a rectangle, and a right triangle to form the figure shown, which is the best estimate of the area of the figure in the square centimeters. Again, we have multiple choice answers here. So we can use 3 for pi, save ourselves some time and a little bit of a headache. All right, now I'm going to start with the easy one, which is going to be the rectangle. So remember, our formula for a rectangle is area equals base times height. Okay. So here's my base. Right here is going to be 6, because remember, it doesn't matter if it's top or bottom because opposite sides of rectangles are the same, so that's 6. And this is going to be the height of my rectangle, 4. So when I plug those numbers in, I get 6 times 4. That's going to give me 24. Okay, so next thing I'm going to do is I'm going to look at the semicircle because I know that measurement. I don't have to hunt for any of those measurements right now because that measurement is given to me because what I need, remember, for the area of a semicircle is pi r squared. Now what's important though is because it's semi, that means it's only half a circle. So my formula is going to be the area of the semicircle is 1/2 pi r squared. Okay. Now again, remember we talked about composite figures share sides. So the semicircle is sharing a side with the rectangle. Okay, well, what side is it sharing? Well, it's sharing this side right here. Now we know that distance goes all the way across from this point to this point. And again, going back and reviewing our vocabulary, the distance all the way across circle through the middle from edge to edge is its diameter. I don't need the diameter in order to solve its area. What I need is its radius. So if the diameter, and I'll write this up here, is equal to 4, radius, remember, is half of that, and half of 4 is 2. So when I go back and plug in for my formula now, so I get A is equal to 1/2. Remember, we're going to substitute 3 for pi this time because we have multiple choice. 3 times the radius, which we found would be 2. And let me erase this so that way you guys can see that. Squared. Okay, now remember, 2 squared is saying 2 times itself. Right, so 2 times 2 is 4, so I'm going to simplify that. And 4 times 3 is 12. So when I simplify, I get 1/2 of 12. And half of 12 is going to be equal to 6. So the area of my semicircle here is 6. Okay, so now I have 2 of the 3 shapes. So now let's talk about the triangle. Now the triangle is a little bit more difficult to find. And here's why. Well, again, what do we know about rectangles? If this side over here is 4, that means the opposite side is 4. And again, what we look for in height of a triangle is this guy right there, the 90-degree angle. What the 90-degree angle is showing me is that, okay, this distance right here is the height of the triangle. Well, we know that from the rectangle that it's 4. Okay, again, a shared side. What's tricky here is, well, what is the base? Okay, well, what do I know? I know that the area from, or the length, excuse me, the length from this side of the rectangle all the way to the end of the shape is 10. I also know, based on rules of rectangles, that the distance from here to here, though, is 6. So I have to ask myself, what do I need to add on, or what's left over to get all the way to 10? Well, to determine that, you can just say, well, 6 plus what gives me 10, or you can look at it the other way and say, 10 minus 6 is equal to what? Well, in this case, it's going to be 4. Okay, so then that gives me the base of my triangle. Now, going back and reviewing formulas, for a triangle, A equals 1/2 base times height. So now I just need to plug in my numbers. So I have A is equal to the 1/2 of 4 times 4. And then I get 4 times 4 is 16, so I want to know what is half of 16. Let me change colors, stay consistent. And half of 16 is going to give me 16 divided by 2, which is going to give me an area of 8. Okay, so now we have our 3 numbers. So let's go ahead and add those up so that way we can figure out the total area of the shape below. Or excuse me, the given shape. So let's look at the 3 numbers here. So we have an area of the semicircle of 6 plus an area of the, sorry about that, guys. Go back. 6 plus 24 plus an area of 8. Well, 6 plus 24 is going to give me, we'll go to blue, give me 30 plus the 8 for a grand total of 38. So my answer is D. So again, where's your common mistake? Sorry about the glitch there. So you can fast forward through those few seconds. But again, 38 is the answer. What's your common mistakes? Common mistakes might be I used the wrong diameter. I used the diameter of 4 instead of the radius of 2. I might have used 3.14 and not gotten the right answer. Another way to use 3 is they say estimate. Estimate, we're definitely going to look at using 3 for pi instead of 3.14. Okay, so all right, so make sure you make your corrections and again write your words while you got it. Okay, last one, question 5. This is a repeat question from an activity you guys had from earlier in the year, earlier in the unit. Again, this is going to be a combination of adding and subtracting here. Now, the key is in the word problem, the foot of a garage needs to be painted. Of a garage needs to be painted. The total area, except for the door, will be painted. The door is 7 feet high and 8 feet wide. So what that's saying is that I'm not going to paint anything in blue. I'm going to leave it alone. Okay, so we do have some shaded region. So the door is a shaded region. Okay. Well, also what we need to get from there is, I'm going to move that out of the way, is the fact that we have measurements here. The door is 7 feet high and 8 feet wide. So let's go ahead and just add those in so we know 7 and 8. So the first thing I have to do is determine the area of the whole thing. Now the whole thing is going to be broken up into two shapes. So if I draw a line here, okay, I get another triangle, and I'm going to add that to the base, which is the rectangle, the bottom of the rectangle. Okay. So my two formulas I have here, and again, you guys don't need to memorize these formulas. They are given to you on your star chart. So always, always, always refer to that star chart. You guys will get what you need from there. Now, it's not going to give you the answers, obviously, but it will guide you in the right direction. So first thing I got to determine is, well, what is the base and what is the height of the triangle? And then I also need to look at, well, I have a base times height on a rectangle. I like to start with the rectangles because they're easy. So you get a base of 12 and a height of 8. And so over here, 12 times 8. Okay, that's going to give me 96. Now I need to do the triangle. Now the triangle, we have to use the rules of rectangles because they share sides. So if the bottom of the rectangle is 12, that means the top of my rectangle is going to be 12. It's also going to be the base of my triangle. Now again here, remember, with height of a triangle, we're looking for 90-degree distance. So basically what I'm asking is, well, what is the top distance from the top of the triangle straight down to the bottom? In this case, we don't see the 90-degree angle, but because it says from here to here is 3, we can assume that my height here is 3. So let's plug it in. So A is equal to 1/2 times the base, which is 12, times 3. 12 times 3 is 36. So I'm going to come down here and finish the problem. And half of 36 is 18. So my area of my triangle is 18. Okay, so the next step to do is say, okay, well, what do I know? I know the whole shape. If I take 96 and I add 18 to it, let me just erase that. I get a grand total of 9 plus 1 is 10, plus 1 more is 11, 114. Okay, so I know the whole shape is 114 feet squared. But if I'm actually, this is pretty close to a real life situation, is when you guys eventually grow up and own your own houses and you have to paint your homes, you don't want to paint your garages because they're made of different materials. So you need to figure out, well, how much paint do I need to buy? Well, I don't need to paint the whole front. I just need to paint what is non-garage door. So I got to figure out the area of the garage door. Okay, well, they told us that the area of the garage door is 8 by 7 or 7 by 8, and it's also in the shape of a rectangle. So we're going to use our formula, area equals base times height. And I'm going to plug in my numbers. 7 times 8. Again, it doesn't really matter what order you put them in because it's multiplication. Doesn't matter how you multiply. 3 times 2 is 6. 2 times 3 is 6. So 7 times 8 is 56. Okay, so what do I do now? Well, I have total area. And I'm going to subtract the area of the garage to give me the area of what I need to be painted. So when I borrow, 14 minus 6 is 8. This becomes 10. 10 minus 5 is 5. 58. So common mistakes. A lot of you guys circled 56 because you thought that's what we were asking for here was the garage. A lot of you guys did 114 because you forgot to go back and subtract 58. And then 76 is 96. Oh, anyway, so go ahead and make your corrections. This is going to conclude the reteach retest. Make sure you turn those in to your teachers. That the way you get credit for it. Remember, you cannot retest unless you've completed the corrections on this reteach video. If you have any questions, please don't hesitate to contact myself, Miss Elise, or Miss Mendoza, whoever your teacher is. And I hope this helped, and good luck on your retest.